Okay, so we now have to do the second half of chapter 6. So the first half was all about polynomials and graphing them and understanding them, and now we want to talk about solving them. Just like solving any equation, a quadratic or a linear equation, solving it means finding those solutions, finding those x-intercepts. And so one way we can solve them is to factor. But think about these that are like degree 3, degree 4, degree 5. That's not how we normally factor, and so we need to look at some different ways that we can factor. One of these ways is looking at sum and difference of two cubes. And I showed at least, I think I showed all the classes this, but at least a couple of the classes last semester, we did a worksheet where I showed you there's a formula of how to factor a perfect cube plus a perfect cube and a perfect cube minus a perfect cube. And if you have a plus b cubed, that factors into a plus b times a squared minus ab plus b squared. And that looks really scary for people, but it's not really that much to do, and especially after you practice it a few times, which you're going to get to do. And for the subtraction, the difference of two cubes, all that changes are the first two signs. So I'll show you what I mean. So a cubed minus b cubed factors into a minus b, and then a squared plus ab plus b squared. So the big thing is when you're factoring cubes, a perfect cube plus a perfect cube or a perfect cube minus a perfect cube, you just have to figure out what a and b are, and then you just plug them into the formula. And yes, you have to know these formulas. Other ways to factor, and this is on page 369 in your book, this exact same chart. We reviewed all of this first semester except for the cube part, but remember you have the good old GCF that you can always factor out. You always want to look for that first, and then this just kind of breaks it up by the number of terms. So if you have two terms, remember that you can have the difference of two squares, or now we can also have the sum or difference of two cubes. And when you have three terms, that's what I like to call undoing FOIL, right? Where we have to kind of work backwards. Maybe we do factor by grouping. There's some special cases of that, but honestly, if you just remember undoing FOIL, and then 4 or more, we have factor by grouping. So let's just practice a little bit of this. So number 1 here is 4 terms. The only way we have to do 4 terms is to factor by grouping, and sometimes it's kind of grouped together for us. Sometimes you have to group it together. I'm just going to group together these first 2, and I'm going to group together the last 2, and I'm just going to factor out the GCF. So in that first one there, they don't have any numbers in common, but they do share x squared. So remember that factoring is kind of like dividing it out. So if I take x squared out of x to the third, then I have 1x left, and I still have this 5, but I took out the x squared. So that's really just x plus 5. Factoring is like undoing the distributive property. And you could check that. If you multiplied this back in, you would get back what we started with, right? And remember, if you do factor by grouping correctly, you should get the same thing over here. So when I see negative 2x minus 10, I'm going to take out a negative 2. And again, dividing by negative 2 would give me a positive x. And negative 10 divided by negative 2 gives me a positive 5. So those are the same. So now I can take out the x plus 5s and put together what's left, which is x squared minus 2. And we're not solving these yet, but we're going to this week. The difference between factoring and solving is an equal sign, right? This isn't equal to anything, so I'm just going to leave it alone. These would be the factors of the polynomial. If it was equal to 0, then I could solve it. So that's really not new. We did that last semester. But look at number 2. Number 2 is something that looks different, right? So one thing you might think of, oh, is that the difference of 2 squares where I get like a minus b times a plus b? No, because of x cubed, right? So if it's x cubed, it has to be a perfect cube number. So now you have to figure out, is 400 a perfect cube number? And I'll make sure I show you this in class, but we want to say, like, can you take the cube root of 400? And there's a button on your calculator that can let you do that. And it's not. 400 is not a perfect cube number. There's no number times itself 3 times it equals 400, which means we can't do anything to this, all right? And so we can say that this one's prime. That means it's not going to have an answer. Maybe it's imaginary, maybe it's just irrational. But let's look at one we can do, like this one. Step 1, always look for a GCF. So GCF on this, I can take a 3 out, I can take an x squared out. So if I divide by 3, I get 8. And if I take x squared from x to the 5th, I have x to the 3rd plus 3 divided by 3 is just 1. So I take out the 3, I took out the x squared, and I'm just left with y to the 3rd. So now look what's left in these parentheses here. It's a cube number and a cube number. So you have to figure out what would a and b be here, right? So this would be like your a to the 3rd right now, and this would be your b to the 3rd. So I'm going to write that formula over here again. That's how I memorize formulas, is practicing writing it. So a cubed plus b cubed factors into a plus b times a squared minus ab plus b squared. And so what is a? Well, what number to the 3rd power equals 8? Well, that would be 2, right? Because 2 times 2 is 4, and 4 times 2 is 8. And then x to the 3rd is just x. So a is 2x, and b, what to the 3rd power equals y to the 3rd? That's just y, right? So a and b are, what are they before you take it to the 3rd power? So I have to leave this 3x squared out here. But then to factor what's left, it's just going to be a plus b. So that's going to be 2x plus y. And then a squared is next. So if I square this number, 2 squared is 4, and x squared is x squared. And then minus a times b. So a times b is just 2xy. And then plus b squared. Here's b. So that would be plus y squared. And so this would be my factored answer. And that trinomial right here will never factor again. Like, that is never going to be factorable in this formula. And I know that seems kind of scary at first, but the more practice you get, the better you'll be at it. So I think maybe I have one more. Maybe I should have done this one before number 3, because number 3 had a GCF and looked extra scary. This one, again, how do you know if it's factorable? Well, if it's only 2 things, it's either squares or cubes. Definitely not perfect square, but 27 is 27 a number cubed. And again, maybe you want to write these out. Practice them, right? Well, 1 to the 3rd, I guess we could include that. 1 to the 3rd is just 1, so that's a perfect cube number. 2 to the 3rd is 8. 3 to the 3rd is 27. 4 to the 3rd is 64. 5 to the 3rd is 125. And you can always use your calculator to do that. But those are kind of cube numbers that you want to be aware of. So when I see 27, I know that's the same as saying 3 to the 3rd minus y to the 3rd. And I really like to write it like that because that lets me see that a is 3 and b is y. And again, I'm just going to write my formula out here. The difference of 2 cubes is now a minus b times a squared plus ab plus b squared. And so if you know what a and b are, right, I'm just going to plug that in. 3 minus y times a squared. 3 squared is 9. A times b, and again, ignore the sign there because you're just taking the letters. 3 times y, so that's always going to be plus 3y in the difference. And then the last one squared would be plus y squared. And what's really cool is if you distribute that, if you work it all out, everything does cancel except for the 27 minus y to the 3rd. And maybe you can try that out and make sure that it works. But that's kind of the big focus, being able to factor these so that then we can solve them and find those solutions, those zeros. So I think that's all I have. Yeah. And so tomorrow in class, we will work on these problems and practice doing them.